you to get out of this course. Not only to know some cool places around, so we're going to nice hikes around here, so you know your mountains around here, but also for you to gain a lot of literacy about how geological maps are made and what kind of information is actually in them. And along those lines, what we are going to do is we are going to construct a little geological map for this mountain today. And to start with this, we're going to construct a geological cross-section. Part of my motivation here is that from the field reports as well, it seems that we need to work a little bit on cross-sections and about how to put in actual data we measure into a cross-section and project at depth and project way up in the sky. This is how, you know, once you decide you're going to become a miner, and you know, you're going to be able to tell me, you know, where the certain rock is a kilometer beneath that we need to drill. So this will come in later in life, you know, once we basically have the big apocalypse and we have to go back to the gold standard, and you become, you know, a Mad Max freelance, you know, gold miner. This will pay back in spades. So, you know, you've been throwing up geological maps. This is a random one. This is like over by Titus Canyon. But, you know, you look at these geological maps and there's like all these colors, there's all these projections, you know, these cross sections, and you're like, well, God, are these guys making this up? Like, are they imagining this stuff? You know, is this just like when Francis goes on the board and does these, like, you know, drawings of things at depth? Well, no, I mean, how these are actually made is if you start to look at the map and where these cross sections are, you can see there's all these little measurements, these structural measurements, and those are the strikes and the dips, and those are the projections of the beds at depth. And so by mapping in 3D and getting the projections of the beds, they're able over the space to actually project in both down into the earth and up into the air above the topographic profile, where these structures go into the air. And so to try to do this for this mountain, we're going to start with basically an exercise of making a box diagram. And we're going to make a box of this fold because it's kind of hard to visualize. You look at it here and it's like, okay, I'm seeing white rocks that are all kind of folded up. And it's even, you know, more of a problem when we're going to go up Aliso Canyon and hike it. When you're in a tight canyon, like all you see is kind of upright white rocks. And it's like, how does this structure actually, you know, project when I'm looking down, you know, from a satellite, you know, from a map view? Okay, and so what we're going to do is we're going to basically construct this box diagram so that then you can use the top of your box to be the actual map, and then this face of the box, it's going to be the start of your cross section that you're making. So if you get out, everyone get out the field guide, and you see in the field guide, you've got the back page is a box. The second to last page is a topo map. And so you're going to make this topo map into a geological map. And the third to last page is a topo profile. And you're going to make that into a cross-section that is actually a quantitative cross-section where you're actually putting your data, the measurements you make, onto this map and to reconstruct these folds and reconstruct the stratigraphy and unconformities through this range. So in the end, you're going to make something that is a much smaller version of this with a nice cross-section like this and a little 3D box model as well. Okay, so this box is a box. You know, in the write-up here, I was like, when I was trying to write this exercise, I was like, okay, I'll have them bring graph paper and they'll make a box. And I was like, oh, everyone's gonna have these like different shaped boxes. It's gonna be a mess. I was like, oh, I'll just make a box and I'll give it to you guys. So here's sort of the box that I wanted you to make. I mean, it doesn't really matter other than you actually visualizing this as a box and being able to measure the surfaces. And so what we're gonna do is we're going to, the best we can, basically draw this face, and we just take our time and actually try to get the angles the best we can on this, but also measure what face that you're measuring. So try to use your Brunton compass to get what the angle is perpendicular to that face, because you're going to put this fold on this face here, and then we're going to go around 90 degrees to the other face, and we're going to draw what this fold looks like in a 90 degrees different angle. And so you start to look at it and you're like, so I can see some of these things folding around, but like I don't know exactly which way is stratigraphically up or stratigraphically down in this fold. And then if I go around 90 degrees, like will the beds be tilting that way or will they be tilting the other way? And depending on which way, so you just have a 2D cut, and by seeing 2D here, you don't know like how this fold is actually projecting. It can be on a lot of different axes, and suffice being here. But if you get one more face, right, that's going to constrain the different angles these beds can be at, and then you'll have enough information to reconstruct where the top is, which is what you see in a map, right? And that's when you see a fold axis on a map, that's going to be the top face. So, you know, what I want you to do is basically, we're going to find where this face is on our topo map. Yep.
Can you explain how you're explaining how you draw it on the...
Yeah, I will in a second here. So I'll get us where we are first. Yeah, so we're at 1.1, okay? So we're right here. And what we're our box basically is going to be this hill here that goes right through the cross section. Okay, so we're going to basically draw this face, and if you can use your Brunton and walk around here at an angle, you know, you can walk this way or this way to get an angle to where you are drawing an angle that's as parallel as possible or orthogonal as possible to this line, then you should be able to accurately make your box be parallel to that face, right? So that when you make your cross section, all you have to do is just take it off the box, right? So basically, if we wanted to, who's got a Brunton, or I'll show you how I am mapping these days. So let's get an orientation of this face. Okay, I'm going to zoom in on this spot. Okay, so there's where we are looking at this face. And I'm going to go, all right, here's the orientation. So that's the orientation. So I'm using this basically as a plot. So you guys can use your button to make an orientation measurement. But I want my face to be basically perpendicular to that line. So you guys have these protractors here. So what's the orientation of this line on here? Okay, that line is running at 20 degrees to the west or to the east of north. Okay, so it's running at 70 degrees. So if I wanted to do 100, what bearing would I go if I wanted to do perpendicular to that? So 20 plus another 180, about 200. Okay, so basically I want to get to a position where I'm doing a drawing that's bearing at about 200. So let's see, that is 20. So I guess I basically have 200 here, huh? Looks like
Did you say 70?
Yeah. So 20 degrees from north.
Yeah.
Right. So here's north. Right. So we just go 20 degrees. So a bearing of 20 or 200 would be this line. So we want to go perpendicular to it. So we want to go to a bearing that's basically looking that direction, right? Mm-hmm. So what is that bearing? 180 would be 200. That's just that line. Oh, that's not right. That's not perpendicular. We want this line, right? So what is that? What? 110. Yeah, so 110 would be this way, or plus 180 would be 290. Okay, cool. So we want to go 290 going this way. So you guys have your Bruntons out? So you guys can measure this and figure out what orientation we want to go at here to line up with our cross section. There's protractors, there's colored pencils, there's pencils here. We're gonna make a nice colored map here where we're putting together this giant fold. Does anyone have a guess what formation this is? What are we looking at?
Cold water?
No, no. This is a hint. This is the most important formation in all of California. It's the Monterey Formation. So this is what's exposed on the coast, but it's been thrust up here against the Santa Ynez Fault and into a big fold.
Are there any more buttons?
So yeah, share your Bruntons. There's only about I think 13 of them because other classes have been taking them. Okay, so if I'm taking a photo of this, 290 this way.